Getting power to remote locations in difficult terrain is a big problem. And that was the primary motivation for Emrod's team to develop a wireless power distribution technology. If we go to the next slide, the problem that we're addressing is that connecting remote geographies is often economically unviable to lay power lines due to the terrain, rights of way. If you put microgrids, you have theft of solar in the remote areas. We need faster responses to disaster relief. Diesel is just not a sustainable approach with the global efforts to reduce climate change. And in sensitive areas, it's just culturally unviable to lay power lines. So let's go to the next slide and look at the technology. 100 years ago, Nikola Tesla had a concept, the same concept with very very different technology to ours. But a lot of people ask, why now? And so there are really two reasons. One, the technology is here. Emrod has proven that we can send power long distances in a safe, efficient, effective, and a cost-effective way. And climate change is really, it's like the wind behind our back, and it's just now is the time to deploy this technology. Let's go to the next slide and talk about how the technology works. If you look on the left side, where it says safety, you see a transmitting antenna on the very far left side. What we're doing is we're converting DC power to electromagnetic energy. And we're sending that power over a frequency of 5.8 gigahertz to an antenna that is rectifying that power back into DC. We have IP around the system, including sending the power longer distances through a passive relay you see on the right side. Very quickly on the safety components, the antennas are high up, just like power lines. We have a safety curtain that immediately shuts off the impacted beam if a bird flies through. And the beam, as you can see, that blue beam is a columnated controlled beam that does not have dispersion like cell towers do. Let's go to the next slide and look at some of the use cases that we've had from global companies inbound. Just looking at infrastructure, power infrastructure, powering remote cell towers, disaster relief, decarbonizing industry like mining, space. But I'm really excited to tell you, if we go to the next slide, talk about our beachhead market, which is to target the oil and gas industry that is a cause of a big part of our climate problem. There are hundreds of thousands of gas flaring sites that need to be addressed. And the big ones can be addressed by extending the pipeline or taking that gas and putting it into liquid and shipping it off. But for the smaller sites, it's really difficult to eliminate the methane that's going into the environment. So what Emrod can do is produce the electricity from that raw gas and send it to the closest substation on the grid and get the feed-in tariff for a revenue model that makes that process of cleaning up flaring an economically sustainable approach. If we go to the next slide, we can talk about some of the competition that is mainly around laser sending wireless power. And laser has issues with high power levels and when you have bad weather, it really gets distorted. If we go to the next slide, here you're looking at a picture of our indoor lab prototype that's sending 2 kilowatts of power over 36 meters. The field prototype that we are doing for our first customer, which is called PowerCo, the second largest utility company in New Zealand. That same system will send 2 kilowatts of power over 220 meters. And for a proof of concept for the flaring, we will be sending 500 kilowatts over 2 miles. So we are really excited about moving forward. And the next slide is just talking about the ask for government. We are open to supporting your efforts with some specific R&D, both in DOE and DOD. On the corporate side, we are looking for support in deploying our proof of concept for the flaring industry. And for investors, we are going to be going out for a larger round, our Series A round in the next few months. And we're open to talking with you and just seeing if you want to participate in the future of wireless power distribution. Thanks so much.
Awesome. Thank you, Sam. Open up the floor for questions.
I have a couple of quick questions. One is, what is the cost per kilowatt hour now, and what are you targeting?
Today, it's our first prototype, and the cost really is dependent on the efficiencies we reach and the capital costs. Today, the efficiencies are quite low, but we have an exciting roadmap to improve those efficiencies. And the efficiencies really are based on 3 aspects of the technology. One is converting from DC to microwave power. The second one is the actual beam itself, which is already at 98%. And then the receiving antenna, we have our own internal process to improve the efficiency. So it's difficult to specifically answer your question as we develop the technology and the different use cases. But I just wanted to kind of give you a general roadmap.
Do you have a kind of a range or an idea, at least as a target and theoretical, possibility?
Today, I don't. Yeah.
Awesome. Tina.
Thank you. For your transmission, is it like, do you have the line of sight issue that you're sending, and it has to be a really clear sky, not overshadowed by any canopy effect? And I want to know the loss. Where are you at right now in terms of the power loss?
Good questions, Tina. We do need line of sight, and that's why we put our antennas high up above the trees and above anything that could be impacting that line of sight. What was the second question that you had, Tina?
Power loss.
Oh, the losses. Right now, we're end-to-end efficiency of 35 to 50%, and we have a really exciting solid-state technology coming on board that will improve the losses to, we believe, in a theoretical 95% efficiency.
Okay, last question was to Corey.
Yes, sir. This is Corey Anderson here from Architect. When looking at this, obviously, like you said, it's very directional. It's a beam. You're in the 5.8 gig range. How much effect on other EMI is present in the environment? That's a Wi-Fi band. Are you bleeding out and killing Wi-Fi? And are you having a lot of other EMI effects? And just how much of the spectrum are you using at 5.8 gigs? Over.
Yeah, that's a good question, Corey. So at 5.8 gigahertz, what's key to our technology is the collimated controlled beam that we are able to obtain that does not have any dispersions like you'd see from a cell tower. So we haven't tested it in the field, but we believe that there will not be any interference, as long as it's not in the direct line of sight of the beam. I think that answers your question.
It does for the most part. How much
Yeah.
of the spectrum are you using there at 5.8 gigs? Is it a 10 megahertz channel or 10 gigahertz wide? How much of a part of the 5.8 gig spectrum are you using?
I don't know, but I can get back to you on that if you send me an email. I'll put my email in the chat and ask the technical team.
Great, thanks so much.
Awesome. Thank you so much, Sam.